السلام عليكم. أعزائي طلبة الصف الثالث، محاضرة الإحصاء لهذا اليوم عنوانها Measures of Central Location، وهي إكمال للمحاضرتين السابقتين حول Descriptive Statistics. At the end of this lecture, you are expected to know the following. You should know the three measures of central location, their definition, and you will be able to calculate these measures for both grouped and ungrouped data, and how to choose the most appropriate measure of central location for each data set. Just to remind you about types of statistics. Statistics divided into two types, descriptive and inferential. Descriptive statistics include two aspects: presentation of data, and summarization of data. Presentation of data you have already covered in the previous two lectures, which is in the form of tables or graphs, and today we will start with summarization of data. What do we mean by summarization of data? Summarization of data is simply calculation of summary measures to give us an idea about the whole data set. And they are of two types: measures of central location, which is the subject of our lecture today, and measures of variability, which will be covered in the next lecture. Measures of central location can be defined as number or summary figures that tend to cluster around the middle of a set of values or observations. These are certain figures, we will calculate them, and they usually tend to be present in the middle of the set of the observations. Another name for the measures of central location is measures of central tendency. Measures of central location mean mode and median. There are three measures of central location which you should know, and their definition, their calculation, and when to use them: the mean, the median, and the mode. There are other measures of central location, but you are required to know only these three commonly used measures of central location. Now, the first measure of central location is the mean, arithmetic mean. وهو أيضا يسمى باللغة العربية المعدل الحسابي. It is simply the average of all values or observations in a distribution. معدل مثل ما نسمى معدل طالبة بالإعدادية مثلا كمثال. And it is calculated by this formula: the mean is sum of the observations divided by the number of observations. يعني معدل طالب بالثانوية مجموع درجات الدروس تقسيم عدد الدروس نحصل على قراءة معدل الطالب، which gives us an idea about the whole mark. يعني كل الدرجات مالته نختصرها برقم واحد نقول هو المعدل، ويصيرنا فكرة عن كل الدرجات. Formula for ungrouped data لحساب المين for ungrouped data or what is called raw data is by this formula: x bar equals the summation of x divided by n. X bar is the symbol or الرمز للsample mean. And when we say arithmetic mean or mean of the sample, it is x bar. And this summation means مجموع. This is the summation is مجموع the sum of all the observations. يعني نجمعهم ونقسمهم على عدد الobservations. So as for ungrouped data, the mean is calculated by this formula by summation of all the observations and divided by the total number of observations. As I've mentioned, x bar is sample mean. Population mean is denoted as mu. So these symbols هذه رموز لازم أن تعرفوها وتميزوها. X bar is the sample mean, while mu it is the population mean. راح ناخذ أمثلة about how to calculate the mean from ungrouped and grouped data، وراح نطبقها طبعا عمليا في إن شاء الله
دكتورة بالكلاس.
The first example is about calculation of the mean for ungrouped or raw data. In this example, the reported time on the internet of 10 students are 0, 7, 12, 5, 33, 14, 8, 0, 9, and 22 hours per week.
طلاب استمعتوا للدكتورة؟ طلاب جاي تسمعوني؟ جاي تستمعون للدكتورة؟
صباح الخير. العفو
دكتور.
صباح الخير.
تكتبوا بالشات.
ما بالكلاس أي ما كلاب.
So, as I mentioned, this example is about calculation of the mean for ungrouped data. We have 10 students. They were asked about the hours per week they use for the internet, which is measured in hours per week. So we have these readings. So what is the mean time of internet for these groups? Time on internet for this group. So calculation simply x bar equal to, as I mentioned, summation of x divided by n. So we will add these observations, the values of the 10 students, and add them up and divide them by n, because there are 10 students, so the total number is 10, and we got the mean, which is 11 hours per week. When you calculate the mean, you have to put the units. The mean has the same units as those of the variable. Now, for group of tabulated data, to calculate the mean, we should follow the same formula, but we should add the frequency to the formula. So the mean for grouped or tabulated data is the summation of frequency multiplied by x divided by summation of f, which is the sample size. And now we have two examples about how to calculate the mean for tabulated or grouped data. This example 2 is calculation of the mean for a variable which is quantitative discrete variable. Here we have number of previous pregnancies. X is the number of previous pregnancies, which is ranged from 0 to 4. And we have, this is the frequency. This information was obtained for 101 women. They were asked about the number of previous pregnancies for them. So in this table, as you see, 18 of the women, they had no previous pregnancy, 35 had one previous pregnancy, 24 had two previous pregnancies, 18 had three previous pregnancies, and 6 had 4 previous pregnancies. So from the table, this variable is quantitative discrete variable. Total sample size 101, and this is the table. So by application of the formula x bar equals to summation of fx divided by summation of f, first step we have to multiply the frequency by x. So for the first group, for the first class, 18 multiplied by 0, which is equal to 0, 35 multiplied by 1, 24 multiplied by 2, and so on. Then the results of this multiplication will be added up and From this, we get the summation of fx, and by dividing this summation of fx on summation of f or n is 101, we get the mean number of digit pregnancies, and it was 1.59, which should be approximated to 2, because as you know, for the discrete quantitative variable, it will take only integer figures. So the mean here is equal to previous pregnancy. The other example, the third example, is for a data list of quantitative continuous data. As you can see in this table, it is the distribution of the age of children, 100 children, whose age range from 1 to 11. And from this, you can see we have class intervals. So this is age here calculated as a continuous quantitative variable. And also we have the frequency. The difference between calculation of the mean for continuous quantitative data from that for discrete quantitative data is that in the case of continuous quantitative data, x would be the midpoint for each class interval. For discrete variable, x is the variable itself. Here we have the midpoint. So the midpoint, first thing we have to calculate the midpoint for each class interval. And you know how to calculate the midpoint. We take the lower limits of two successive classes and add them up and divide it by 2. So the midpoint for the first class interval is 1 plus 3 divided by 2 equals 2. The next group, 3 plus 5, 8 divided by 2, 4, and so on. Then we will follow the same previous procedure by multiplying the frequency by x, so 18 by 2, 20 by 4, and so on, and then we sum them up, get summation of fx divided by summation of f. This is the sample size is 100, and we got the mean age of these children, it is 5.46 years. And this formula, this is the calculation, summation of fx divided by n. So it came just to show how it was calculated. Now, what are the characteristics or the properties of the mean? As I've mentioned, the most important aspect of the mean is the most commonly used measure of central location. If there is no contraindication for the use of mean, you always select the mean as a measure of central location, and you will find that out in the coming lectures. In most of the differential statistics, we usually deal with the mean. So it is the most commonly used measure of the three measures of central location. In the other characteristic, it uses every value, uses all the observations. As you have noticed, when you calculate the mean, each observation in the data set will enter in the calculation of the mean. The third property is that for each set of data, there is only one mean. And the most important point for the mean, which is a disadvantage of the mean, it is that it is influenced by extreme values, whether on the high or the low side. This is the main disadvantage of the mean. So it is affected by extreme values. That's why when we have extreme values, where mean is not the most appropriate measure of central location. And as you can see here, a simple example, we have 5 observations, 1, 3, 5, 7, and 9. If you add them up, you get 25 divided by 5, you get a mean equal to 5. If one of the observations, the 9, substituted by a larger number, a same number, which is away from the other figures, became 24, directly the mean became 8, which is quite different from the 5. If this 24 hours, if this observation more than 24, 30 or 50, so the mean will be larger and larger. So it will not represent the data set. So the only situation in which you shouldn't use the mean as a measure of central location is when you have mean value, whether on the higher side or on the lower side. The second measure of central location is the median. The median is the middle value when the observations are arranged in ascending or descending order. For calculation of the median should be the value which is in the middle of the observations, but we have to arrange them either in ascending or descending order. How to calculate the median? We have to follow certain steps. First of all, for ungrouped data, the first step, we have to arrange the observations in ascending or descending order. رتبها من أقل قراءة إلى أعلى قراءة أو بالعكس. فعادة يفضل أنه من الأقل إلى الأعلى. So the first step, you have to arrange the data. Then you have to find the position or the order of the median. We said the median is the middle value, the value which divides the observations into two equal halves. So we have to find which observation is in the middle. So we have to find its position, and then we find it out. Median position can be found by this simple formula n plus 1 divided by 2. So therefore, if n is an odd number, the median is the middle observation. If n is an even number, يعني إذا n عدد فردي راح يطلع لنا نجمع وياه واحد ونقسمه على 2 يطلع لنا رقم واحد، هو هذا يعتبر يكون middle value. If n is even number، إذا عدد زوجي الميديان راح يطلع لنا رقم بنص، فناخذ 2 middle observations، يعني راح يصير عندنا 2 middle values. So we'll take the average of these 2 middle values or middle observations. راح نشوفكم بهذا المثال أيضا. سنرجع إلى نفس المثال about the time on the internet for the 10 students. To find out the median, the first step we have to arrange the observations in ascending order or descending order. Here they were arranged in ascending order: 0, 0, 5, 7, 8, 9, 12, 14, 22, 33. And so after arranging, we have second step, we have to find the median position, and it's 10, so 10 plus 1 divided by 2, 5.5. So we have 2 middle values. When you get this such a figure, so the fifth and the following figure number the mid value. So we have the fifth value, this 1, 2, 3, 4, 8 is the fifth value, and the following value the sixth value. And we take the average of these two values, and it will be the median. So 9 plus 8, 17 divided by 2, we have, so the median here is 8.5. And the odd, when the number is odd, and suppose that we exclude this 33, the last observation, and we leave only 9 observations. In this case, the median position is 9 plus 1 divided by 2, so it will be the fifth observation. And we go back 1, 2, 3, 4. The fifth observation is 8, so the median here is 8. So there's no need to have average on. We have only one middle observation, and it is the median. For calculating the median for tabulated or group data, also we have to follow certain steps. The first step, we have to calculate the cumulative frequency. So in ungrouped data, we have to arrange them in ascending or descending order first, and then find the position. And for grouped or tabulated data, we have to calculate the cumulative frequency, and then also we have to find the position of the median in the same way, median position n plus 1 divided by 2, and then we go back to the table to find out the median or the median class from the table. So we go back to the example for calculation of the median for tabulated or grouped data, the same previous example. We have the number of previous pregnancies. As I've mentioned, first step we have to calculate the cumulative frequency, and as you see, the first group, and by now you know how to calculate the cumulative frequency. The first group will be the same 18. Then we add the frequency of the preceding group and so on. So the cumulative frequency is the frequency of the same class interval plus all the preceding classes. Now حسبنا cumulative frequency, then the position of the median 101. We have the sample size n is 101 plus 1 divided by 2, so we get 51. So the order of the median or the position of the median is the observation number 51. And so we go back to the table and we found that observation number 51 is, its value is 1. So therefore the median here is one pregnancy. One pregnancy. For calculation of the median for continuous quantitative variables, we also the same procedure. We have to calculate the cumulative frequency, and then we find the position of the median, n plus 1 divided by 2, the 50.6.5. So the median is, the value is 50 and 51, average of the two values. We go back to the table and find that 50 and the 51, both they are located in this class interval. So our conclusion would be the median class is 5 to less than 7. For continuous quantitative data, that's what is required from you is to locate only the median class. There is specific formula to calculate the exact value of the median, but it is not required from you. So you just find out the median class. You will say that the median class is 5 to less than 7, which means that the median is somewhere between 5 to less than 7. But there is a formula to calculate the exact value in the PDF lecture which I sent. It is present, but you are not required to remember it or use it. Now, what are the properties of the median? The median, as I've mentioned in its definition, it divides the observations into two equal halves. 50% of the observations above and 50% below the median. The second feature, which is similar to that of the mean, for each set of data, there is only one median. So for any data set, we have one mean and one median. And what is important about the median, it is not affected by extreme values. It is different from the mean. That's why when we have extreme values, we usually select the median as a measure of central location. And you will notice that the same previous example, in the 5 observations, the first 5 observations, the median is 5, and when the observation, the fifth observation became 24, the median remained the same. So it is not affected by extreme values, and we should choose the median as a measure of central location if we have extreme values. The third and the last measure of central location is the mode. The mode is the most frequently occurring observation or value. Simply, it is values have the highest frequency, which occur most frequently. This is for ungroup data. So we have the 9 is repeated 3 times, 5 repeated twice, 12 repeated twice also. So the highest frequency here is 9, so the mode is 9. The second set of observations, there is only one of each, so there is no mode, which means that the data set does not necessarily have a mode value, but each data set should have a mean and a median, but not necessarily have a mode. For tabulated or group data, to find out the mode, it's very simple. You look at the frequency, and the highest frequency is the mode. This is very easy for discrete quantitative variable. The highest frequency here is 35, so the mode is 1. Some of the students might make the mistake and they mention that the mode, for example, 35. So 35 is the highest frequency, so the mode is 1 zeta pregnancy. The same for continuous quantitative variable, tabulated continuous quantitative variable, also we find the highest frequency. So here we have 39, the highest frequency. So the model class is 5 to less than 7. So that you are not required to find out the exact value. You just identify or locate the model class, which is similar to the median. For the median class, and for the model class. Now, what are the common features of the mode? It is first feature, which is similar to the median. It is not affected by extreme values, but it will take the highest frequency value only. The second important thing is that the set of data may have no mode, 1 mode, 2 modes, or more. Mentioned for the mean and the median, for each data set, they have only 1 mean and 1 mode, 1 mean and 1 median, while the mode, there could be no mode, could be 2 modes, it's called bimodal, or could be more than 2 modes. So this is the only one we have, could be no one, 2 or more. Now, if you ask what is the relationship between the 3 measures of central location, the relationship between them depends on the type of distribution. You will have a lecture about the types of distribution. But just briefly, while we mention them, the distributions are usually divided into 3 types: symmetrical, normal distribution, and we will have a special lecture about normal distribution. Or it can be positively skewed, in which there is extreme values on the higher side, positively skewed to the right, or negatively skewed, in which there are observations which are extreme on the lower side, or it's also called less negative, less skewed distribution. If the distribution is symmetrical, the mean, the median, and the mode are equal and located in the middle. And we say that methods of central location are usually tend to cluster in the middle. So normal distribution, they are all equal and located in the middle. But when it is skewed, not symmetrical, for example, this is the positively or right skewed, and positive skewed is also called right skewed distribution. Here, we have the long tail to the higher side, which means that we have extreme values on the higher side. That's why the mean will be the highest value. The median is always located in the middle. So in the positively skewed distribution, the mode has the highest value, then the median is the middle, and the mode is the lowest value on the lower side. The median in the middle, and the mean would be the highest value, because we have the value to the high side. So the mode is the least, less than median, median less than mean, which is the opposite in the case of negatively or less skewed distribution, which have extreme values on first side, lower side. So the mean will be the lowest value, less than the median, and the median less than the mode. Median always in the middle. Mean for negatively skewed is the lowest value. For positively skewed, the mode is the lowest value. And here I have three multiple choice questions. You need to look at them and think about the answer. Question 1. Which of the following statements about the median is true? This is about the median. You read each one of them and find which one of them is true or it is a property of one of the characteristics of the median. First, it is a measure of grade order. This is, of course, wrong because it is a measure of interlocution. B is a useful summary measure when the data are skewed to the right. This is the right answer because, as I've mentioned, median is not affected by extreme values. So that's why when we have skewed distribution, whether to the right or to the left, whether negatively or positively skewed, the median is a good choice as a summary measure for central location. C is greater than the mean when the data are skewed to the right. This is wrong. So the mean is the highest in any skewed distribution to the right or positively skewed distribution. Can be distorted by outliers. Can be distorted by outliers. This is wrong because the mean, which is distorted by outliers, while the median is the best choice for a distribution which have or outliers.